Yeah. Are we?
Yeah.
What is it? I think it says we can go through it as a group, or did y'all have any questions on it?
Mm, let me think. Can I learn up? Um, I was confused for a while about did why they added the number back in, or why they times it
Yeah.
by the number that it was.
Yeah. I
Like
agree.
if you roll a six, then why do you times that by a six? That was really kind of strange to me.
I agree. I didn't really understand that. I just did it and then I got the right answer, but I don't understand why you do that either. It just seems kind of weird.
So I looked at that. I mean, I was looking at that all day yesterday. I was like,
Yeah.
I
I
didn't
looked
find
at it
that.
for a while too and I was like, why do you do this? So I don't know. Any thoughts, Kelsey?
I don't know either.
Yeah,
I'm getting the textbook up.
yeah, yeah.
Okay, got that up. Where did it go? So yeah, I don't. But then yeah, it works out at the end
Mhm.
because the one is very high and the one is very low. When you start timesing it by one, you get a very low number, and when you start timesing it by six, you get a very high number. And by the end, I guess it all averages out.
Right. Yeah.
And so I'm just trying to work in my mind the difference between the sample mean and the population mean, and I think I got that.
Mhm.
The sample mean was the one that they had actually rolled the dice 6,000 times. So that was an actual sample. The
Right.
population mean was just the average. It had a probability of 1/6 of a time.
Right.
So it made 3,000. Oh, yeah, it made 3,000 of a difference because the population mean was 3.5 and the sample mean was 3.503.
Right.
So anyway,
Yeah.
whatever.
I know. It is quite a bit confusing. Yeah.
So anyway, it's just a lot of steps to get to, you know,
The
the
answer.
standard deviation. So did you look at your quiz and you figure out what you did?
Um, oh, I haven't. I forgot to do that. I do need to go in there and look. I forgot she said she was going to post them after everyone did it. Yeah,
Yeah, I was looking at that, and the one thing, let's see. Well, the one I missed. I got the first quiz fine. The second quiz I missed two.
right.
One was I just read it wrong. It said how much of the data is between 2 points. I thought it said 4 and 6, but it
Uh,
said 4 and 8. So I put 25% because I thought it meant the middle line, but it means the whole box. So in the
right,
box in the box graph, the data that's in the box is 50%.
right, right.
Anyway, so I just misread that one.
Yeah, I think a lot of the questions though on these quizzes are kind of like you have to read them like a couple times, two or three times because it's almost like it could get you like because I did that on
Right.
the first one too. So
And the second one I missed did get me that way. It said the stand is talking about the standard deviation. If the number changed, they wrote the number down wrong as 12, his age in the study about the ages. They wrote it down as 12 and it was supposed to be 21. And I put that the it would, what did I put?
deep,
Okay, I looked at the data and it was an odd number. It was 99
right,
things. And so I put the median would not change because that was the middle number. And if it's an odd, then the middle number would still be the same. That's what I thought. But then the answer was that it couldn't be determined.
right, because there
Uh,
wasn't enough information. Yeah,
Anyway, so I thought there was, because it was an odd number and it was the median was the middle number.
Mm-hmm.
And so I thought it would be the same. But anyway, I got that one wrong.
Yeah, I know. They're a little tricky sometimes. I have to really think about it. All right. Well, so let's see. I went over and did the preparation. Do y'all want to try to start the quiz now, or do you think we need to go through the assignment first?
Well, it's just asking the mean. Was it number 5? Is that what you're looking at?
Yeah, there's 2 questions.
Yeah, there's just 2 questions about a 4-sided die.
Right.
We could go over that a little bit.
It's funny because if you actually just, like, you can do the whole, like, I don't know if it was just a fluke, but if you actually just find the mean how you're supposed to find the mean, it's 2.5. Do you know what I mean?
Yeah.
Doing that whole table. But I don't know if that's normally how it would work out. Because, you know, yeah. Because if you actually add 2 plus 3 is 5 and divide it by 2, it's 2.5. But I don't know. It's the same. So, but I think she wants us to learn how to work it all out, you know.
Yeah, and then to subtract, see the value, that it just seems kind of strange, because that's the part that's confusing to me. When you put the value in, and then you, like the last one, 4 minus 2.5, and then you square that, and then you multiply it by 0.25.
Right.
But see, you could have a die with a cat face on one side and a dog face on the other. You know what I'm saying? You could not have a number there, and so what would you do if you didn't have a number there? You know, how can you divide by cat? You know, you can multiply, or you know.
I don't know. Maybe
Anyway,
I think it might be based on, like, even if it's like a cat and dog, it's still a face to the die, so you'd still use like 1, 2, like to how many?
You'd have to give like cat equals 1, dog is 2, and elephant was 3. Okay.
Yeah.
Yeah.
Okay. So give it a value the first
Yeah.
one. Okay. I see.
Yeah. Okay.
All right.
Well, do y'all want to try to start the quiz, or?
Okay. Sure.
Okay.
Let's give it a start. Let's start this one. Completed.
Sure.
Okay. No, all the probability answers are decimals. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population in the United States with each of these blood types is summarized in the table. Use this data to answer the following question. The blood type and the proportions given in the table above define a probability distribution.
The probability answers as percent. Blood can be classified into one of basic types.
Well, it equals 1. It equals 100%. So, I don't know. What do you think? I'd say yes, but
Yeah. If it equals 1, then it can be
a
probability.
What do you think, Kelsey?
Same thing.
I know it's early there. Did you have fun yesterday with your?
Yeah. Thanks for doing this. Yeah, we went sledding yesterday. We were like 40 minutes outside of town.
Fun.
We were there all day. It was super fun, but now I'm like super sore.
Yeah.
I'm tired too.
Good exercise.
Oh, totally.
Okay, let's see. Number 4. What is the probability that a randomly selected person in the United States has type O blood? round 2 decimal places.
So they randomly.
Type, what is probably that random?
Oh,
A
this is
randomly selected person in the United States.
0.45. So it's 45% of the population of the United States has type O blood. So wouldn't it just be 0.45? Am I trying to oversimplify that, or?
That's what I was thinking personally.
If you randomly select it, is
We don't
that is this let's see, proportion of people in the population of the United States. Okay.
Yeah, I think that's right. I mean, it's not asking for the variance. It's not asking for the standard deviation. I think it's just probably 0.45.
Seems like when I did the other homework, because I did the other homework that we're supposed to do on our own. Let me see something.
Okay.
Did it not give did it say don't give percents though?
Right. It says decimal, so.
All right. Select a person in the United States. All right.
So
Yeah.
that's 0.45.
I wonder.
Yeah.
Because the next one says, what is the probability that will not have type O? And so that would be 0.55.
Right.
Just adding all the others together.
Okay. Yeah.
So, okay, Kelsey, read the next one.
I gotta shrink it down. There we go. Oh, maybe that didn't work. Alright, my computer screen is technically broken, so I have to like adjust everything.
Oh, sorry.
So no, you're good. You're good. I just had it in the lines of the broken screen. Okay, Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing a specimen from the bladder cancer patient? Round the answer to the 3 decimal places.
So there's 6. So what do you think?
Okay.
It's just 1/6, which is converted into a decimal.
Right.
Right.
Okay.
What, 167?
Yeah.
Okay.
What are y'all putting?
0.167? Is that what you got? Number 7, in a combined total of 54 trials, the dog correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? There's little evidence that the dog can detect bladder cancer, or this provides strong evidence that the dog can detect bladder cancer. So it tells you right there in the question. It is very unlikely the dog could do this well by random chance alone. Yeah. So I would say the second one, there's strong evidence that they can detect bladder cancer.
Yeah.
Even though they'd only done it less than half of the time, they did it more than 0.167 of the time, you know. Way more. They did it 22 divided by 54.
Yeah, it comes out as 0.4.
Yeah, 41% of the time.
So you're putting that this provides strong evidence, or
yeah.
Oh, strong?
Yes.
Okay.
Because if it was random, it would be only, a sixth of the time, or 0.167, and it's 0.41. So.
Combined all 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times.
You might think that it's not true because it's not even half the time. But there's 6 samples.
Yeah.
So it is over. It's.
Right.
Yeah. Makes sense in the end. It just hurts the brain getting there.
Yeah. All right. M&Ms are small chocolate candies. The M&M website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. Brown is 0.13, yellow 0.14, red 0.13, blue 0.24, orange 0.20, and green they don't give.
0.14.
If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? Round answer to 2 decimal places. 0.13?
Yeah, that was hard.
What is the probability that randomly selected candy green? So we just need to subtract or figure out what's left. 1. So it's 0.16.
16% is green. Yeah, that's what I got.
Okay.
0.16.
Mm-hmm.
Okay. What is the probability that a randomly selected candy is not green?
That was 0.84.
Yeah.
I just had that on my calculator. So yeah. Okay. Not too bad so far. The ACT scores of students admitted to a medium-sized public university in the western United States was taken from capex.com. The following summary statistics were calculated. Okay, the mean is 24, standard deviation, variance. Okay. Use the information from the public to answer the following questions. Half of the observations are less than or equal to what number? Okay, that would be half. Oh, that one could be a tricky one.
Mm-hmm.
Less than or equal to what number?
You would say, you might say the median, but then you could say Q3, which is 50%. What do you guys think? Because the Q3 means 50% of the people got or less than, or 50% or less.
Is Q3 50 or 75?
Oh, you're right. Q3 is 75.
Okay.
Q1, 25 of the median. Okay, so you're right. I was thinking wrong.
Okay, so half of the observations are less than or equal to what number? Okay, so it has to be all those that are less than. Okay.
24?
That's what I'm thinking. Would the mean have anything to do with it too? Or is it just the median? That one's directly in the middle.
Well, for this question, it's just the median, or Q2, I guess it's Q2.
Yeah.
Q1, Q2, that's, I guess, what confused me. And then Q3, yeah, median. Just thinking back to that last one I missed, and it's like, wait, there's 50% in the box. Okay, never mind.
Okay, so if it's half, then that would be the median. Less than or equal to what number? Or equal to.
Less than or equal to 24.
Okay.
Then, based on the information on the table above, the top 25% of the students scored above what number? Above what number?
Okay. So, based on the information, the top 25% of the students scored above what number? So the 25 is Q1?
It's Q1.
Q1 is 22.
Yeah.
So that's what I was going for.
About number. Yeah, I think that's probably right. The top 25% scored above what number? Yep, 22.
Yeah.
Okay. And the last one. This one might be. Each of the following statements is not one of the three rules of probability. The probability that an outcome will not occur if 1 minus the probability that it will occur. Well, what? I think it's probably that one.
Yeah, that's what I thought. I just read it. It's like,
The probability is a number between 0 and 1. Okay, that's true. The sum of the probabilities is 1, yes. If the probability is high, then the probability is positive. If it's low, then the probability is negative.
No.
That one sounds weird too.
Yeah, that's
Okay.
That's my first one. There we go. Just different.
Probably that will not occur if 1 minus.
Yeah, that's one of the rules. The last one is one of the rules too. So
Yeah, because the outcome will not occur as -1 is the third rule.
right, it's the third rule.
Yeah.
Okay.
So it's the third one. All right, Kelsey, you want to submit it?
The what?
Yep, here it goes. Brace yourselves.
Which one did you guys say it was the first one for the last one?
No, it's the third.
Oh, we got one. Oh, 2 wrong.
No? Okay, just a second. I'm still looking at that last question.
It's the third. It's if the probability is high, then the probability is positive. If the probability is low, then the probability is negative. That's not one of the rules.
Yeah.
Oh, see, yours are mixed up from mine.
Oh.
That's why
Yeah.
I was like, the third one, that's not right.
Oh, I'm sorry.
The third one of mine is the sum of the probabilities of the probability is 1. And I said, that's right. I've got to look back at my notes.
That's weird that they mix them up on everyone's. I don't.
Yeah.
What did we score, Kelsey?
We missed 2.
Huh.
We
Okay.
got 12 wrong and 6 wrong.
Oh.
So
Oh.
maybe it's just the way I put them in, but for some reason.
Isn't that the one where we put like 1.16?
Yeah.
Huh.
I don't know. Because I put 0.167. And then for 12, I just put in 22. So I don't. I guess there's a different answer.
Right. Okay. Well, that's weird.
Yeah.
I know. I wish we could kind of see.
Yeah. Get a review of what we did.
Yeah. Because it's like, how do you know how to.
How to fix your problem.
Yeah. Oh, well.
It's not bad, though.
Oh,
Not bad.
good. All right. Well, do y'all want to try to meet again on Wednesday, or do y'all want to do it on Thursday morning? What's best?
Wednesday will work for me.
Yeah, Wednesday. Thursday morning I've got a meeting, so.
Yeah, actually, I have something on Thursday morning too. So yeah, I forgot.
Wednesday is fine.
Okay.
I don't have FHE, so we're good.
Okay. All right. Well, thanks for meeting, everyone.
Yeah.
Hopefully it won't be confusing. It seemed like it was pretty straightforward, and then it's like, wow, that's weird. Why
Yeah.
it's different.
I think they're like they just try to trick us on something.
Yeah, that's true.
Yeah.
It's tricky. All right.
Well, we'll see you guys on Wednesday. Okay.
Yep. Yeah.